So today we're going to take a look at how we can find the limit values of a piecewise defined function. And we have a piecewise graph given us at the top of page 28. We're going to initially use this graph to actually write the piecewise equation. And then once we have the equation, we're going to pretend that we don't have the graph. And then we will take a look at some of the limit statements below and how we can evaluate those based off of the equation. Now, since we have the graph, we can use that to kind of check or validate our solutions, but again, we're going to try to pretend that we don't have it. So if you take a look at the graph, it looks like we have three pieces. We have a line and then a parabola and then another line. So let's first try to figure out the line of our first piece. We're going to have to figure out the slope and the y-intercept. So if we try to calculate rise over run between two nice points, that looks like to be a slope of -1. So we can write -1x. And if we were to continue that slope, our line looks like it would cross at -5. So our b value is -5. Let's go ahead and move on to the parabola. So to help us write the equation of a parabola, we can look at the vertex and maybe use some of those transformations. The parabola opens up, so we don't need a negative out front. And the vertex was moved left 1, so we'll have a +1 inside the parentheses, and then down 6. And let's take a look at the other line. So another slope between two good points. Looks like we go down 1, right 2, so our slope would be -2. And if we were to continue that slope towards the y-axis, it looks like we would cross at -1. So there are the functions. Let's go ahead and move on to the constraints or the domain of each piece. This first line can go all the way to the left, so we can say -infinity, and it will end at the x value of -3. Now we cannot reach -infinity and we cannot touch -3 because of the hole, so our inequalities will just both be less than symbols. The parabola starts at -3 and ends at 2. We cannot touch -3, so just a less than symbol, but we can touch 2, so we'll need a less than or equal to. And then for the last piece, we go from 2 to infinity. And we cannot reach either one of those because of the open circle, so they will both be less than. Alright, so now that we have our piecewise defined function, we're going to pretend that we don't know the graph, and we're going to move on to some of these limit statements. So just by using the equation, we're going to try to find these limits and confirm our results based off the graph. If a limit doesn't exist, we'll be sure to state why. So for our first limit, we want to approach 2 from the right-hand side. So this is when we're going to take a look at our constraints and try to pick the one equation that has values to the right of 2, meaning bigger than 2. And if you take a look at your options, that would be this constraint or domain right here. So to help us figure out this value, we're going to use this equation, because that's the equation that fits this x approaching number. And our first step in a limit is to always do direct substitution. So if you plug in 2, -1/2 times 2 is -1, and then subtract 1, we'll get -2. Alright, let's check out b. Now b, we want to approach 2 from both sides. So we have to go ahead and see which equation or equations we would have to use. So if you take a look at your constraints, notice how 2 is used in 2 of the constraints. So this parabola equation has numbers less than 2, meaning from the left, and this one has numbers bigger than 2, meaning from the right. So since this is an overall limit, we have to check both sides to make sure they actually match. So let's go ahead and check out the limit as x approaches 2 from the left. So that would be numbers found within this constraint. So we're going to use the equation of x plus 1 squared minus 6. And then using direct substitution, plugging in 2, we'll get 3 squared of 9 minus 6 will give us 3. Now looking at this overall equation, We know that coming from the right side of 2, our height is -2, but coming from the left side of 2, our height is 3. So the overall limit at 2, therefore, does not exist because the left and right limits don't match. And we can see that on the graph. Okay, here's our x value of 2. As we come in from the left, we're approaching that height of 3. And as we come in from the right, we're approaching that height of -2. Let's go ahead and check out C. So we want to approach -3 from the left. Go ahead and take a look at your constraints. Now, -3 shows up in both of them, but we got to figure out which one would be best to come in from the left. So this constraint has x values that are less than -3, so we're going to use this equation. And direct substitution, always first, plug in -3, we'll get 3 minus 5, which is -2. This time let's approach -3 from the right, so we want to use x values that are bigger than -3. That would show up and satisfy this constraint. So we'll go ahead and use that equation of the parabola. Direct substitution is your first try, so plug in -3 plus 1 is -2, square -2 of 4, and subtract 6, which would be 2. Alright, let's just confirm it on the graph. Here's the x value of -3. As we come in from the left, we approach -2, and as we come in from the right, we approach -2. Looking at -7, notice how this is an overall limit, so we want to make sure we come in from the left and the right. -7 would actually fall within this constraint, and notice how this constraint or domain also includes values to the left and right of 7. So we really only have to test this equation since -7 is completely found within that constraint. So plugging in -7, we would have, oh wait, I used the wrong one. -7 actually falls within this constraint. Okay, silly me. So again, -7 is completely within there, so we just have to use that equation. Plugging in -7, this changes to +7 minus 5, which would be 2. Okay, just to confirm on the graph, because I almost made an oopsie, there's -7, come in from the left and the right, and we approach 2. Checking out -1. Okay, -1 is completely found within this constraint, so we're only going to use that equation. And direct substitution, we'll get 0 minus 6, or -6. So as we approach -1 from the left and the right, they're meeting up at -6.